Good morning, guys. It is April 29th, 2020. I hope everyone is doing well. Our focus question for today is, we know we can transform a polynomial from expanded to factored form by factoring out the greatest common factor. But does that always work? Are there other ways to factor polynomials? What is the difference of squares theorem? So this is building off of what we talked about yesterday. First thing I want you to think about is this. What does it mean to factor a polynomial? Pause the video and think about that for a second. What does it mean to factor a polynomial? All right, hope you were able to think about that. So when we think about factoring a polynomial, really what that means is rewriting our polynomial from expanded form to factored form. So if you notice here, I have an expanded form polynomial, and now I want to write it in an equivalent way but in factored form. So right now, one of the tools that we have is just factoring out the greatest common factor. So the greatest common factor of 9x to the third power and 18x. Look at my coefficients. 9 is the largest number that goes into 9 and 18. And then we know each of these terms have at least one x in them. So I'm going to factor out 9x. And that means in parentheses, I have x squared minus 2. X squared minus 2. Okay, so that's what it means to factor a polynomial. We are just writing a polynomial that's equivalent from expanded form to factored form. Now, yesterday, we also saw that there's other tools to factor, because factoring out the greatest common factor does not always help. So we realized if you have a polynomial written in this form, a squared minus b squared, which is an expanded form, we could factor that into the quantity of a minus b times the quantity of a plus b. And that's called the difference of squares theorem. So theorem just means like rule, and that always works. So if you have a polynomial written in that way, it will factor. So a squared minus b squared is the same thing as the quantity of a minus b times the quantity of a plus b. So that being said, let's take a look at some polynomials here. So 7 squared minus 3 squared. When I'm looking at this, I see this is already written as a difference of squares. And I know that because this is a number squared. This is a number value squared. And when we say difference, we notice we're subtracting. So it's a difference of squares. If that's true, then I could rewrite that as the quantity of a minus b times the quantity of a plus b. So let me identify what the parts are. So let's highlight this. 7 is the a value. 3 is the b value. So I'm going to rewrite it as 7 minus 3 times a plus b, which is 7 plus 3. And you're going to notice they're equivalent. So let's just do the math to check it. 7 squared is 49. 3 squared is 9. 49 minus 9 is going to be 40. So this is 40. Let's check the other side. 7 minus 3 is 4. 7 plus 3 is 10. 4 times 10 is also 40. So notice they are equivalent, 40 and 40. All right, let's go to the next one. 100 minus 9. So remember, in order to use this theorem, difference of squares, it has to be written as a difference of squares. So what I'm looking at 100 minus 9 here, I notice there's a difference. We're subtracting, but we don't see that square. So we don't see to the second power, right? So it's not written as a square number. But if you think of 100, I could write 100 as a square number. What times itself will give me 100? It's 10. So instead of writing 100, I'm going to write 10 squared. That's also like taking the square root of 100. Square root of 100 is 10. So I could also write, I have to write the second number, 9 as a square number. How do I write 9 as a square number? It's 3. 3 to the second power is 9. So now, once again, take a look at this. 10 is going to be my A value. And 3 is going to be my B value. So it's written as A squared minus B squared. Now I'm going to rewrite it in factored form, which is A minus B. So 10 minus 3 times 10 plus 3. And we're going to notice they're equivalent. Kind of ran out of space there. So this is 100. 10 squared is 100. 9. 100 minus 9 is 91. Over here, 10 minus 3 is 7. 10 plus 3 is 13. 7 times 13 is also 91. So what we are doing, though, that was just checking it. The goal today is to, rewrite our polynomials in this difference of square form and then factor it. This is what we want to do. We want to write it in factored form. All right, so let's go to the next one. 16x squared minus 25. Notice, notice it's a difference, so we're good. We're subtracting. Now I need to write it in, and I need to make sure that the quantities are squared. So, and this is what we were doing yesterday. 16x squared, we could almost write it out like this. 16x squared. So what times itself will give me 16x squared? Turns out it's going to be 4x, because 4x times 4x is 16x squared. That's my A value. What times itself will give me 25? It's 5. This is A. 4x is A. 5 is B. So we could rewrite this as remember, A minus B, 4x minus 5, times the quantity of A plus B, which is 4x plus 5. That means this quantity is the same as this quantity, but now it's written in factored form. So if I was solving equation, I could use zero product property. So remember, difference of squares is a way to factor. All right, guys, I'm going to give you a moment. I want you to do 100x to the fourth minus 49. I want you to factor that using the difference of squares method. I'll give you, pause it right now and take care of that, and then let's come back. All right, guys, so remember, the first thing we need to do is write it as a difference of squares. So something squared minus something else squared. 100x to the fourth. What times itself will give me 100x to the fourth? That's going to be 10x. You know what? Let me get a little more space here. That's going to be 10x squared. Because 10x squared times 10x squared is going to be 100x to the fourth. What times itself will give me 49? Remember, that's also like saying, what's the square root of 49? 7. So we have A and B, so we're going to go, remember this guy, this first one is A. And the second term here is B. So now we're going to write it as the quantity of A minus B times the quantity of A plus B. So if I rewrite that, 10x squared minus 7 times the quantity of 10x squared plus 7. So, a couple of things to point out. Remember, we could always write a squared minus b squared if we factor it as the quantity of a minus b times the quantity of a plus b. So, our exit slip for today is factor the following polynomial using the difference of square method. So 36x squared minus 100. This will be in the Google chat. And I want you, when you're answering your exit slips, to private message me the answer. So it's kept private so everybody gets the chance to figure it out on their own. All right, guys. Nice job today. Make sure you keep up. You're doing a good job of that. I've been getting emails, questions through the chat, through email. Make sure you are looking at my comments, correcting your work. Remember, if you prove through your work that you understand the concept, you will earn full credit. If, let's say you get a couple wrong and you need still some work on it, I'm going to send you back some feedback. Once you share that with me or resubmit it and show me that you understand what you missed, then you will earn full credit, 10 out of 10. All right, guys, have a good day.